Good afternoon, friends. The second problem for me for the day, and we are doing some problems on pressure in fluids from the book ICSE Physics for class 9. And the problem states out here is a force of 50 kgf is applied to a smaller piston of an hydraulic machine, neglecting the friction. That means there is no loss of pressure anywhere along the path. Find the force exerted on the larger piston if the diameter of the pistons are 5 centimeter and 25 centimeter respectively. So let's see what kind of diagram it. Okay, great. Now we got the diagram, and the diagram looks quite wow kind of a thing in terms of this is this smaller piston that you were talking about, and this is this bigger piston you're talking about. If you just put some force on the smaller piston out here, like the F1, we can even lift a car. In real life, that's how it happens. You go to a car repair shop, and then you see that the small, they put the car on kind of a place, and then they push something or pump something, a small thing, and the car started rising up, and they can go below the car and repair the car. So, or in a lift or an hydraulic car lifter, this same principle happens. So what's the force that we are exerting in F1 is how much it is. Let's take green because it is the force that you are giving. It's at 50 kgf. So F1 is 50 kgf. And what's the area? We don't know the area of the piston. This is the piston, this is the piston, this is where I'm forcing, and this is forcing the liquid down, and this thing is going total and pushing this piston up. So okay, so the area is not given. Saying again, the diameter is given. So this is a circular piston kind of a thing. It's just a side view. If you see it from top, it is a circular thing. And the diameter is given as 5 centimeter. So the radius is 5 by 2, that is 2.5 centimeter. Okay. So, and what else is given? Okay, this second piston, this piston, again the diameter is given as 25 centimeter. Okay, so radius will be 25 by 2, that is 12 and a half centimeter. Great. So again, we know by Pascal's law, the pressure that is here, if it is P1 and if this is P2, is the same. In that sense, it's pressure everywhere. Here, anywhere we measure, the pressure is the same. Thanks to Mr. Pascal, he told that, and we follow him, sometimes blindly, but it helps us to do a lot of problems. So pressure is equal to force per unit area, as we have told in the previous problem. If you have seen that problem number 10. That force is sometimes also given as kgf. Kgf is nothing but amount of force or amount of weight any body with mass of 1 kg will exert, kind of a thing. If you multiply kgf into g, that is 9.8 meter per second, you get it in Newton. But here in kgf, we will get our answer in kgf also only. So let's put pressure, that is P1, as, or what is the force? F1 is given as, like they have given, okay, it's 50 kgf. And what's the area 1? Area 1 is nothing but it's a circular thing, so it's like pi into this r, or this r, we let it point at smaller r, and this is the big R because it's a bigger piston. So small r square, 2.5 square. For I think it will be easy for us to understand. Let's not make it 2.5. Let's keep it 5 by 2. So I think it's easy for a lot of people to understand. fractions than decimal 5 by 2 square, and we just transfer it into meter square, because it doesn't really matter, but we do it as a practice so that we don't forget, because so P2, the pressure on piston 2, we don't know the force, so we put it at F2, and again this is pi r is nothing but 25 by 2 whole square into 10 to the power minus 4. So according to Mr. Pascal, P1 is equal to P2. So we'll just go to the next page, because I can't write really small, my stylus is really fat. So go to the next page and we'll try to put this and this value, and we'll see how we can find out. So P1 is equal to P2, and value of P1 is force by the force is 50 kgf, and the area was pi r square, where r was 5 by 2 square into 10 to the power minus 4. If it equal to, obviously P2 is nothing but F2 by, again, pi 25 by 2 square into 10 to the power minus 4. This goes off, and even the pi goes off. Kind of just use different color. What we are getting is out here is 50 divided by 5 by 2 whole square. 5 by 2 whole square is nothing but 5 square by 2 square, that is 25 by 4. This is F2. 25 square is 625. If you don't know, you can do it, or just do the calculation beside by 4. Sorry. Now we know this 4 goes up. It's like division of division. It's like it goes up here and this goes up here. So ultimately not making a difference, because it's like it cancels out on both the sides. So 50 into 4 by 25 is equal to F2 into 4 by 25. Now 25, the funny part is 25 square was 625, but we can even keep it as 25 into 25, because see, here there's 125, here there's 125, there's a chance that it cancels out. So we don't have to do the calculation. So this 4 gets cancelled out, this cancelled out, because it's equal to in between. So this means it gets cancels out, kind of thing. So we just go up here, and we can continue writing as, so 50 by 1 equal to F2 by 25. And now we do the cross multiplication. It goes out here and 1 goes out here, so it's like, and we can put like 50 in multiplied by 25 is equal to F2. We can put F2 on the left hand side, just make our life easy. 50 into 25, so 50 into 25, so you keep the 0 aside, because we'll whatever you get multiplying 5 and 25, just put a 0 on the right hand side. So 5 into 25, it's easy, but then we can even do that. 25 into 5 is like 5 5s are 25. We have 2 as extra, so 5 2s are 10 plus 2 is like 125, and so we put 125, sorry, and then we have this 0, just put it here, and the answer is in kgf. So this we have our answer. So we got the answer. We'll just put down in the figure as F2. How much we got? We put it on red, so that F2 we got 1 2 5 0 kgf. See, we get just 50 kgf, and we almost got half a ton, that is 1250 kgf of water force, which was enough to rise the or raise the car on top. So it's easy for any human beings to give 50 kgf. 50 kgf is like, if you're 50 kg weight, you just stand on the piston. It's like a person of 50 kg is equivalent to a 50 kgf force. So you just stand on this piston as a person. If you just stand on this piston, okay, this guy looks thinner than 50 kg, but then it's like, okay, let's make him a bit fat. Okay. So now it looks 50 kg. If you make him stand here, automatically this car is going to rise. See, fantastic, right? Look at the devices. You just go there, stand on this piston, this other car rises up. But be careful, do not jump out of it, because then the car might fall on the person who's just repairing. Jokes apart, but you understand how easy it's to use because of the discovery of this Pascal's law. We now surely know that even a person of 50 kg weight can just raise a car if you have a hydraulic mechanism like this. So it's fantastic. Only what you have to see is you have to check the area of this pistons out here, so that this ratios of this pistons out here, you have to make it such that we can multiply this force. So the only multiplying factor is that area. Whatever the ratio of the area is ratio of this force. So that's conceptually you can visualize, right? Like you guys go and couple of you, or if you have a really fat guy, just make him stand and the car rises up. Fantastic, magic, right? Great. See you guys with more videos on such problems and few more insights of the practical uses of these problems and how we can get benefited. Understanding and knowing and practicing different laws, not just Pascal's law. Thank you.